So here we're supposed to go ahead and look at our velocity curve, which is 10t, which you know is the slope of a line of 10, y-intercept of 0. So we have that graph down here. We have our time, we have our velocity, we have appropriate units, and it says go ahead and find distance. So there's really only two things we've looked at in the first few weeks here, and that is either the slope and the area. One of these is going to help you out and one of them is not. So which one's which? You need to go ahead and look at your units. Suppose we looked at slope. Slope would be change in your y's over change in your x's. Your y's have units of meters per second. Units of your x's is seconds. So then we have meters per second. Instead of dividing by s, you can multiply by the reciprocal, which is 1 over s. So we multiply the top, multiply the bottom, we get meters per second squared. So our slope of this is going to be telling us acceleration, because meters per second squared is acceleration. So in the context of this problem, our acceleration is our slope, so our acceleration is the slope of 10 with the units of meters per second squared. However, that wasn't what we were looking for in this problem. We were looking for distance. So let's look at area. Now, area is going to be the units of your up and down times the units of this. Because if you were going ahead and doing you would go this side here, meters per second, times this side here of seconds, and then you multiply them out and you get meters. Well, meters is the units for distance. So in this case, the area underneath our curve is distance, and that's what we're looking for. So our shape underneath our curve is a triangle. So we've got to go 1/2 our base times our height. Now you're asked to go ahead and do that for the first t seconds. So we're going to go 1/2. If you're going over here t, that would be your base going from 0 to t. And then you got to multiply it by your height. Well, if you're over here 3 seconds, your height would be 10 times 3. If you're over here 4.5 seconds, your height would be 10 times 4.5. So if you're over here t seconds, your height would be 10 times your distance over, which is t, or 10t. So we go ahead and multiply across. Half of 10 is 5. Our t times t is t squared. So our distance traveled would be 5t squared, and then the units would be, in this case, meters. As we look at this one here, you're asked to go ahead and find the distance traveled during the first t seconds of our distance function. Suppose you're looking for your velocity. Well, if we graph this, we have our units and labels here. We know it's just going to be a parabola. Well, once again, there's only two things we've looked at: area and slope. So if we did go ahead and do our area, remember area would be like trying to find the area of a rectangle here. So you'd have to take your side of meters times your side of seconds. And you get meter seconds. Well, meter seconds is meaningless, so your area underneath this curve doesn't mean anything. So obviously we're not looking for area. So we're going to go ahead and take a look at our slope and the units of our slope. Slope would be the change in our y's, which is meters, over the change in our x's, which is seconds, which is then meters per second. So our slope, when you look at the units, is our velocity, and that's what we're trying to find, is our velocity. So we have to do our slope predictor function, our IROC formula, on our distance function. So we've got to go to the limit of 20 times t plus h all squared minus our original function over h. FOIL out the top, distribute through the 20. Our 20t squareds drop. Now everything has an h in it. We can drop the h's out. Now that we no longer have an h in the bottom, we can actually plug in 0 for h. Because if you tried to plug in 0 for h anywhere along here, you would have got an indeterminate form of 0 over 0. But now that we no longer have h in the bottom, we can go ahead and work that out. So we plug in 0 for h, and we get 40t with the appropriate units of meters per second.